Welcome back, Logan, to another episode of Math from Your Couch. Today's a special one, so I want to give a shout out to all my Ewoks off and indoor. May the fourth be with you. But today's topic is going to be talking about what happens when you have lines that intersect in different locations of the circle. So you'll notice that in our three examples here, in our purple example, we have two lines that are intersecting on the circle. So in that scenario, they have two lines intersecting on the circle. In our green example, you have two lines intersecting inside the circle. And then in our red example, you have lines that are intersecting outside of the circle. Here's the thing, we're going to focus today on just the purple and the green. We'll spend a second video on the red one. So our focus is going to be on these two guys here. Now, before we get into it, I want to explain a couple of the lines that are going on here. So in our first example, we have two lines. In our first scenario, we have two lines intersecting on the circle. The red line is what we call a tangent line. The tangent line, the property of a tangent line, is that a tangent line will intersect exactly in one location on the circle. Regardless of how long you draw that red line, it will intersect only at one point, whereas a secant line will intersect in exactly 2 points. Now you'll notice that when you intersect a secant and a tangent, that the lines will intersect each other on the circle. Now, when they intersect on the circle, you're going to have a couple of angles, actually 4 angles, and you're going to have two arcs that we're going to look at. So here's the two arcs. The two arcs are ACD. So our first arc is ACD right here, and our second arc is AB. Sorry, I said ACD, I meant ACB. So ACB is the first arc, and AB is the second arc. You'll also notice that we have two angles. We have 4, but two angles that I've marked out for you, angle 1 and angle 2. Now, the property of that is right here. To highlight that, let's take a look at angle 1. So you'll notice that angle 1 in our property, angle 1 is equal to half of the arc that corresponds to it. So angle 1 is equal to half of the measure of arc ACB, or measure of arc ACB divided by 2. The same thing can be said about the second angle, the green angle. The green angle is equal to half of the purple arc. The measure of angle 2 is equal to the half of measure of angle AB. All right, so let's jump into an example problem. Suppose you have 110 degrees for the angle. What we need to remember is that the angle, the 110, so I'm going to write down the 110, is equal to the arc. Now, I don't have anything there, so I'm going to just write down x for us, is equal to the arc divided by 2. Now, to solve this, since it's a fraction on one side, why not make the other side a fraction? So I'll put a 1 over there, and then we'll cross multiply. This will give us 220 degrees is equal to x. We now know what x is. X is 220. Now you'll notice in example 1, I didn't ask you what to find. I kind of want you to find everything. So the next thing I notice is that I have only part of the circle. Notice the circle is cut into 2 parts. Well, if I have only part of the circle, the other part of the circle must add up to 360. So I can take the 220 and I can subtract it from 360. So I can go 360 minus 220, which comes out to 140. So I now know what this arc is. This arc here is 140 degrees. Now remember, if I have the arc that corresponds to the tangent angle, to the angle that's on the circle, I can just say that this angle, let's call this angle y, the angle y is equal to the 140 cut in half. So that means this angle, angle y, must be 70 degrees. Now this makes perfect sense, because if you look at it, you'll notice that the 70 and the 110 are a linear pair, which means they need to add up to 180. The last two angles that you can find are the verticals to the 110, so this angle right here is 110, and the vertical to 70, which is this angle right there. So this is what you guys are going to be looking at for our first type of problem, the problem where the two lines intersect on the circle. All right, let's jump into our second scenario. In our second scenario, what we have is two secants intersecting each other. Just a brief reminder, secants are lines that intersect in exactly 2 locations. So you'll notice that my red line intersects in 2 locations and my blue line intersects in 2 locations. Now the two secants intersect each other inside our circle. You'll notice that when you have this happen, you're going to have a total of 4 arcs and a total of 4 angles. So I'm going to break that down, so let's label things so we can talk about the angles and the arcs. Now, I'm talking about the two angles, angle 1 and 2, the linear pairs to each other. If you wanted to talk about the angle that's vertical to it, you could talk about those as well, but that can get a little confusing as the introduction. You'll notice that my property says this looks like a bunch of mumbo jumbo, so what we'll do is we'll highlight it. All right, so angle 1, our green angle, is equal to, now this makes sense, is equal to this arc right here, arc AD. The corresponding arc should go with the angle. But what doesn't make 100% sense yet, doesn't make a lot of sense yet, is this arc right here, BC. Now this arc BC is important to include because it corresponds to angle 1's vertical angle. So the way that we say this is that angle 1 is equal to its arc, its corresponding arc, plus its vertical angle's corresponding arc, added together and then divided by 2. Now the same thing can be stated about the second angle. So if I highlight this one for you as well, you'll notice that angle 2, or the purple angle, this one right here, DC, makes sense, and its vertical angle also makes sense. So what we're going to do is we're going to say that angle 2 is equal to arc DC, plus its vertical angle's corresponding arc AB divided by 2. All right, so let's take a look at an example. Our second example looks like this. How do we find x? You'll notice that x actually has the vertical angle 80, and has the corresponding arc of 140, and its vertical angle's corresponding arc is 80. So we can say angle x is equal to the 140, plus its vertical angle's corresponding arc, the 80, added together and then divided by 2, which gives us x equals 220 divided by 2, which is a total of 110. So I now know that x is equal to 110. Its vertical angle is also equal to 110. Now, if you wanted to, you could find their linear pair angles. So this angle here must be 70, and this angle here must be 70. Unfortunately, I cannot find these last two arcs. I know what they're going to add up to. They're going to add up to a total of 140, right? If you double the 70, these two arcs are going to add up to 140. But how much they are, I'm not exactly sure. They might be 70 and 70. They might be 60 and 80. They might be 139 and 1. I have no exact clue what they are. All I know is that they have a total of 140. All right, so the last thing I'd like to do is take a look at two more examples. So example 3 and 4. Example 3 looks like this. You'll notice that you have two variables you're trying to solve for, x and y. X has its corresponding arc as well as its vertical angle's corresponding arc, and y doesn't. So I'm going to go with x first. I'm going to say that the angle, all right, the angle x is equal to, its corresponding arc plus its vertical angle's corresponding arc divided by 2. So we get x equals 118 divided by 2. Now when you divide 118 by 2, we get 59. So we now know that x is 59 degrees. Now solving y should be straightforward. It's an example from chapter 1. This right here is a linear pair, which means that they need to add up to 180. So I'm going to take the 59 away from 180, and this comes out to 121. So I now know that y is equal to 121 degrees. Now you'll notice we don't know the arcs that go with y, that correspond to y, but we can tell you what the angle is. All right, example number 4. Now number 4 is a little goofy. Number 4, you have x and y. You'll notice that x is an arc this time. So what we're going to do is we're going to say that the x arc and the 40 arc correspond to the 70 and its vertical angle. So we're going to say that the angle of 70 degrees is equal to x plus the 40 divided by 2. And then we'll just solve this. I'm going to use cross product, so I'm going to put a 1 underneath it so that I can cross multiply. 2 times 70 comes out to 140, so I'll write that out. We have 140 is equal to, and then 1 times x plus 40, that's an easy one right there. That's just x plus 40. And then we solve the problem by subtracting 40 from both sides, and we now know that x is 100 degrees. So we have the x arc, which is 100 degrees. And the y is just a linear pair to the 70, so we can say that it is 110 because they need to add up to 180. All right, take a look at the examples. Take a look at the problems for tonight's homework, and if you have any questions, please hit me up on email or Google Classroom. Have a good day, and I'll talk to you guys tomorrow.